So Khaled is an irrigation management specialist, as I said, at UC Kearney Ag Center. He's been there for 6 years, but prior to that, he was down in Imperial County as an irrigation specialist as well for over 20 years. So his responsibilities include design, implementing, and conducting educational and applied research programs on irrigation, drainage, water management, water quality, soil salinity, waste management, and reuse of wastewater for irrigation. So with that, Khaled, please start your presentation.
All right, thank you so much, Mary Lou. Good morning. So today I'll be talking about water budgeting and where to find the relevant information, and just very basic things about what we need to do in order to do a good job managing irrigation. So when we talk about water budgeting, there are a few things that we have to consider. And the first thing would be the soil type. What kind of soil do I have? And that has lots of impact on our decision. Basically, we want to know what kind of texture. Do we have a fine textured soil, medium textured, or light soil? Because it has an impact on how much water the soil can hold and make it available to the tree or the crop. That will impact also the irrigation frequency. So if we have a lighter soil and it doesn't have a good water holding capacity, we have to irrigate more frequently in order to make sure that we don't just lose the water below the root zone. And then another thing that is important is the soil type will have an impact on leaching. If we have excessive amount of salt in the irrigation water or in the soil itself, we will be able to determine how often to leach based on the soil type that we have and what type of irrigation system, whether we need to have a sprinkler irrigation or flood irrigation to leach, depending on other factors like slope and so on. When we're dealing with avocado or any other crop, we want to know what kind of irrigation system that we have. And that irrigation system sometimes is related to the soil type. So, whether you're looking at micro sprinkler or drip, the decision is most likely related to the soil type. The irrigation efficiency is important as well. Typically with pressurized irrigation systems, you have higher efficiency. We want to look at the application rate. How many inches are we applying in every hour? So if we're running the system for 5 hours, how many inches are we getting? And we want to compare it to the design, original design of the system. So maybe when I get brand new irrigation system, they will tell me my application rate is 1/10 of an inch per hour during the growing season. And once in a while, I would say at least a year, I want to check that application rate, check the efficiency of that irrigation system. We want to also consider variables related to irrigation system. If I'm irrigating on a slope and I have a farm, part of it is on a slope and part of it is flat, I may want to have 2 different or 3 different zones. I don't want to irrigate everything to the same level and the same irrigation frequency. We want to also look at irrigation water quality, and that has a big impact on the way we do irrigation. And if we want to do leaching, if we have to consider specific ion toxicity. So it's a good idea to know what kind of water that we're using for irrigation. Now, when it comes to determining crop water requirements and irrigation schedulings, there are plenty of methods available out there. Some of it would be based on estimates, like, using the reference evapotranspiration, ETO, and the crop coefficient. And that's basically the simplest method, doesn't cost, hardly anything, because you can get that information from DWR and from so many other resources. CIMIS is the California Irrigation Management Information System. And this system has been around for a long time. And this is actually a good start to get the reference evapotranspiration, since right now they have, spatial CIMIS, and you'll be able to get an accurate reading of the ETO on your farm. There are new methods to determine actual water use. One of them is Thule. It's been around for a few years. We could use plant-based technologies, looking at 3 soil moisture status and make decisions based on that. Or we can look at soil moisture and see if the soil is too dry and when it's time to irrigate. We want to do fine tuning of the water budget based on the technologies available to us and additional factors that we have in the field. So the first thing, like I mentioned, soil texture is relatively easy to determine. We can get an estimate by looking at, the soil maps. In the old days, we used to have big books with a soil map. If you like this method and you have, those soil maps, you can start with that. Right now, it's relatively easy to find the soil map on the web, and there are plenty of sources. We want to check for variability. If I'm farming, 10 acres or 20 acres, do I have one soil type or do I have more than one soil type? And then that will make a difference on how often, I irrigate, whether I'm going to have one zone for the entire field or whether I'm going to have 2 zones. Water holding capacity, which is directly related to the soil texture, as we will see later on. We want to look at effective root zone. Do I have, good soil and deep soil, and my, the plant can go and have a normal root zone, or do I have, shallow soil depth, maybe 1.5 feet, 2 feet? That's gonna impact the way I do irrigation, because if I only have, in one area I have like 1 foot or 2, and then I have solid rock, if I add additional water, it's not gonna go anywhere, and it's not gonna be helpful for the tree. We will also, like I mentioned earlier, we wanna consider leaching if needed. I'm sure you're all familiar with the soil texture triangle. There are so many different soil types, but in general, I like to keep things simple, and maybe we can lump all these soil types in something like we call heavy soil. That's basically something that when you have clay, clay loam, silty clay loam, sandy clay, those are typically heavy soil type. The characteristic of heavy soil type, it has high water holding capacity and lower infiltration rate. So I know when I'm using this soil, I can store a lot of water, and that will impact my irrigation frequency. So if I can store a lot of water, I don't have to irrigate so often. And I can add a little bit more. So, if I have, 1 irrigation a week, I'll be able to apply enough water to meet the crop water demand for that entire week. And we have the medium soil type that has medium water holding capacity. And also I'm looking here at the infiltration rate. So if you have high water holding capacity, you'll have lower infiltration rate because of the soil type. If I have a medium water holding capacity soil, it will have a medium infiltration rate. And now if we look at the light soils, like sandy loam, loamy sand, and sand, those are the soil that have lower water holding capacity. I need to irrigate more frequently and smaller amount, but has higher infiltration rates. And the infiltration rate is very important when we're looking at, other practices related to Sigma, like, if we want to do groundwater recharge, we want to be looking at soils that have medium, medium texture and light texture. So we want to look at these soil types, loamy, silty loam soil, or sandy soil. I cannot do groundwater reshowers on these type of heavy soils because the infiltration rate is low. Fortunately in California, there are so many different sources where you can get the soil maps. And these are, some of these sources. The Web Soil Survey, it's basically the same as the old soil maps that we used to have, 20, 30 years ago. This is what I like, the Web Soil Survey is relatively easy to use. There's the California Resources Lab from UC Davis. There is also the ANR catalog, and we have the traditional, NRCS and RCDs, that's where you can get soil maps. But, for me, I find the Web Soil Survey is the easiest. It will take you maybe about 10, 15 minutes if you never went to that site to get used to it. Basically, it's just very easy. I can type an address, or if I want to look at the county, I can go search by county, and I can highlight my field. And you take a look here at this example, we have two different soil types, like 114 and 124, and there's no need for us to go into details, but you can see here we have two different soil types. So if this is the field that I'm farming, for sure I want to do different management practices based on these soil types. Sometimes these soil types, they're not that different, and maybe I can do the same management practices. I want to look at my existing irrigation system. Like I mentioned earlier, even if I have brand new irrigation system that I installed a year ago, I want to make sure that I check the application rate. Want to make sure the application rate matches what's in the design. And if not, find out what kind of issues I have that is making that deviation from the design. It is essential to have a flow meter. If you bought a system over the last 10, 15 years, I'm sure it comes with a flow meter. If you don't have a flow meter, definitely that's something that you need to get. So that flow meter also, it doesn't stay accurate forever. So if I have flow meter from 15, 20 years ago, maybe it's working and giving me numbers, but those numbers could be inaccurate. In general, I want to check the accuracy of the flow meter every 5 years or so. I want to check the efficiency of my irrigation system. And typically for pressurized irrigation system, it's relatively easy to do, and what we call DU, or distribution uniformity. I want to do this at least once a year. Sometimes, you can get this service for free. Plenty of sources that they will be willing to come and do a DU test for your farm. It only takes like 2-3 hours. Sometimes there are companies who provide this as a service. Want to make sure that I have good distribution uniformity. So anything about 85%, I would say, it's good. Most of the time, if I have a very good drip irrigation system or micro sprinkler, that number could be as high as 90 or 95%. If I have a low number, I want to know what kind of issues that I need to fix to get that number to at least 85%. We want to also consider, whenever we determine crop water requirements using any of the methods that I mentioned earlier, it depends on the irrigation efficiency. So we always divide the crop water needs by distribution uniformity. So if I have lower distribution uniformity, I'm going to apply a little bit more water, which means more money and more energy. We want to consider the water and energy cost. As energy costs have been going higher and higher, over the last few years. Lower efficiency means higher operating cost in terms of water cost and energy. I want to check the flow rate versus the design application rate. That is relatively easy to do, and I can show you later on. This is basically using just a flow meter. You can go to the flow meter and look at the flow rate and just do some very basic calculation to determine, what's the application rate, what's my current application rate. Is it higher than the design rate or lower than the design rate, or it's just about the design rate? If it is higher than the design rate, I am sure I have some issue in the system. Maybe I have a leak, and then I have to walk into the field and find out what's going on or the source of that leak. If I'm going with a new irrigation system, there are plenty of opportunities right now with the sweep and so many other programs that you'll have the ability to apply and get grants to cover 100% of more efficient irrigation system. Now, if I'm gonna go a new irrigation system, I wanna have additional consideration. In the old days, when they design an irrigation system, pressurized irrigation system, energy cost was not a big factor because we used to have like a constant energy rate. Now we have time of use, and in most places, anywhere from 4 to 9 p.m., that is the most expensive energy. And I want to avoid irrigating during that time because, I want to save money. So in the old system design, they used to say, well, okay, in a 24-hour period, I want to irrigate no more than 18 to 20 hours. Well, now with a new system design, if you want to consider energy cost, I want to avoid irrigating from 4 to 9. So my day is no longer 24 hours. My day is now 19 hours. And I want to irrigate for less than 19 hours. And I want to have a few hours, extra if something goes wrong with the system and I need to fix it. So typically with the new irrigation system design, I'm going to get, higher application rate, a little bit different design than the old way. There are plenty of places where you can get information about the new irrigation systems, various irrigation vendors. You can go and say, okay, I have 5 acres and I'm looking at the new irrigation system. What do you recommend? And they will start asking you questions about, how many trees you have and what's the spacing and what's the soil type. And most of the time they can give you a design for free. We have the UC ANR, you have farm advisors all over, you have Ben Faber and, Andre Biscaro, and depending on where you are, you have local cooperative extension office, and they can provide, advice. Consider the CDFA. Soon we're going to have another call for a sweep, and that is also a good way to upgrade irrigation systems. If you don't have a flow meter, you can get a flow meter, you can get soil moisture sensors, and so on. Sometimes there are incentives related to energy, because whenever you improve irrigation efficiency, you're going to use less energy, and that will save you money. And maybe there are incentives to help you with a new system. Crop water requirements, like I mentioned earlier, CIMMYS, the California Irrigation Management Information System, that is relatively easy to use. You can get basic information about daily ETO without creating, an account. And you can just go, look at the county, and you'll find, several CIMMYS stations. You can get very basic information about the ETO in your area. Now, if you want to get a little bit more detailed information and you want to download the data, you can sign up also for, you can click on your farm and you can receive a weekly email telling you what's the ETO over the last week, which I do, for the fields that, I'm interested in. Every Monday I get an email from CEMES saying, okay, these are the ETs for the locations that I have. You know, you can see here on the map, I have a location in Tulare and Modesto, and you know, I can just provide my email and they will send me the ETO. There is the actual reference, actual crop water use. There are new methods like Thule Technologies. That's a service available in California. You pay about, you know, $1,800 a year, and they provide you with the actual ET at your farm. But typically you need a relatively, you know, larger fetch or bigger areas, a few acres. There are other technologies like Arable Mark. That's also another device that you can buy for less than $1,000. You know, they have a subscription service, you know, for maybe $500–600 a year, where you can get the crop coefficient, actual water use, rainfall, wind speed, rainfall, and so many other sensors, temperature, radiation, and so on. So you can Google CEMES, and you'll be able to get to this website, and it's relatively easy to sign up for, you know, for CEMES. Soil moisture is essential. You know, the best thing is to have a soil auger or a shovel and go to the field and see what's going on. So here I'm showing an example of the grapes, and we're all familiar with tensiometers. There is the newer version of the tensiometer, basically much less maintenance and relatively easy to use. It's called Watermark. And you can see these are 4 different data loggers right here. I have one at, you know, different depth in the soil profile. This is in an almond field. You know, so I have soil moisture sensors covering the entire soil profile, you know, but, you know, 1st foot, 2nd foot, 3rd foot, and 4th foot. And with these ones, I can get, you know, reading. And this reading is relatively centibar, which is very exactly the same for soil tensiometer. There are so many other, you know, soil moisture vendors, and I'm using different companies. If I don't want to, you know, I don't want to provide too much information. We don't make recommendation, but you know, if you're interested, you can contact me, and I can share with you my experience with the different, you know, soil moisture sensors on the market. Also, it depends on the budget. A lot of them, they have really easy platform where you can retrieve the information on your phone, or you can download the information from the web. There are services related to, you know, scanning your field from remotely scanning your field and looking at areas where whether you have stress or not. This is series imaging that I like to show as an example. And this is on an almond field in the San Joaquin Valley. You could see, like, you know, this is in April. And I'm looking at, if you look at the red and the yellow, it says high stress and moderate stress. And the green and the blue are, you know, trees are that they're doing good. So when I get an image like this and I see, well, all right, you know, I have areas in my field that they're relatively stressed. And keep in mind, the reason I got this one, because I'm doing variable rate irrigation. So I have the ability to irrigate, you know, smaller zones as small as one acre. So I go later on, you know, in May, early May, and then I adjust the irrigation system, and I see, you know, I need to apply a little bit more water. And you could see here in May, the field looks great. I can check again, you know, 2 weeks later, May 14th here, and you can see that I don't have too many trees that they are stressed. The stress could be related to soil moisture. Stress could be related to salinity. So there are tools, there are commercial services that they can do salinity scan for your field and tell you if there are issues with salinity. You know, for nut crops and citrus, we have here in the San Joaquin Valley, we have, farm advisors who provide weekly crop water requirements for major crops in the region. And that could be another way where I can estimate how much I need to apply. For example, in this case, I can look at the actual ET over the last week and say, okay, was about 1 inch. So I need to apply 1 inch this week. For avocado, there are information available. We go back to the basic ET equation. The crop water use equal the reference evapotranspiration, ETO, which I can get from CEMIS, and the crop coefficient. And the crop coefficient, just take it with a grain of salt, because the crop coefficient, for avocado or for any other crop, I can start with, publications like this one. It says September crop coefficient is 0.6, but that crop coefficient depends on so many different factors, including, do I have small trees, larger trees? Do I have, what's my spacing, and so on. There is a good thumb of rule here, and Mary Lou, I think, came up with this information with Jim Oster way back. And it says the crop coefficient would be about maybe 85, 86% of the shaded area. So let's say for now, let's assume that our crop coefficient is 0.6 or 60%. And that's a good estimate. Now, if I have, lots of shading, take a look at the upper picture right here. This is in Ventura. I took these pictures with the Ben Faber. So you can see this field, you take a look at the ground, there is not much sunlight. So this is the high canopy coverage, and I would expect the crop coefficient would be higher than 0.6, for example. Take a look at another farm, you can look at the tree spacing different. The shaded area is relatively small, so I'm sure my crop coefficient here would be small. I'm sharing with you some of the crop coefficients from Australia. And the reason I'm sharing this, because you can take a look at these crop coefficients. They have, well, keep in mind, they're January or February, it's a summer for us here. So you can see they have crop coefficients as high as 1. The take-home message is, no matter what, you don't want to apply more than reference evapotranspiration. So if the crop coefficient at most is 1, you don't want to apply more than, the reference evapotranspiration times 1, and that would be on the high side. And from there, you can look at soil moisture and make adjustment. If the field is too wet, definitely the trees are not using that water. If the soil is relatively good and I'm applying the right amount of water, then I'm making the right decision. So the crop coefficient has to be adjusted based on your local conditions. And here I'm just going to show an example. Like, let's say, my reference evapotranspiration last week is 1 inch, and my crop coefficient is 0.6. So all I have to do, ETC equal the reference evapotranspiration times the crop coefficient. So that's 1 times 0.6. That's 0.6 inches per week. That's how much my trees lost over the last week. If I have irrigation system distribution uniformity or efficiency of 85%, not everywhere in the field are going to get the same amount. So in order for me to compensate, I need to take that 0.6 and divide it by my irrigation efficiency. And that will come up to about 7/10 of an inch. I want to consider rainfall and whether I have effective rainfall or not. So if I have no effective rainfall over last week, I need to apply that 0.7 inches to replace whatever moisture lost over the last week. So again, I look at my application rate. My application rate would come from the irrigation system design, but better to come from, when I do the distribution uniformity, they will tell me what's the application rate. So in this case, it's very close to 1/10 of an inch per hour. I take the total water that I need to apply, 0.7 divided by 0.09, and then I need to run the system for, about 8 hours this week. If I have a lighter soil, I may take these 8 hours and split them over like 3 irrigation events or 4 irrigation events, 2 hours, 2 hours, 2 hours. If I have a heavier soil, maybe I can do 2 irrigations, or sometimes, you can do 1 irrigation. So this is where the soil type comes in. Sometimes, you can find the crop water requirements based on the number of trees that you have and how many gallons each tree will need. So maybe an irrigation, a farm advisor or somebody will tell you, well, based on what you have in this field, I recommend applying 130 gallons per tree, per week. So you take the 130, multiply it by the number of trees that you have by the area, which is like 10 acres in this example, and I get 195,000 gallons that I need to apply. That's relatively easy to do. Now, the only question is, well, for how long do I need to run the system? This is why you need to have a flow meter. A flow meter will tell you what's going on, what's the flow rate. So all I have to do is take the 195,000 gallons and divide them by my flow meter reading, and that will give me 475 minutes or about 7.9 hours. Other consideration, like I mentioned earlier, the 130, that could be a standard for your area, but could be different for your location based on the spacing of the trees and based on the canopy coverage and so on. So you may need to adjust that. Good idea always to check soil moisture status. Even if you don't have a soil moisture sensor, you can always go there and look, look at the soil moisture by just taking a shovel and feeling the moisture. With the new technologies, this is an example on almond and citrus. Like I mentioned, the Thule technology, that's one of the services available in California. And with this one, it makes things much easier. I don't have to worry about the soil type. They will figure out what's the soil type, based on the NRCS soil type maps, and they will determine the water holding capacity for me and everything. All I have to do is just provide very basic information about the spacing of emitters and my irrigation system and so on. And then, they can provide me with a recommendation. They can show me the actual ET lost on a daily basis. You see, this is an example for citrus. And you can see on a daily basis as well, I'm losing about 0.16 inches a day. And they can say, well, based on what happened in your field last week, you need to apply 10 hours of irrigation this week. And then they will show you, if they have sensors in fields around you, then they're going to show you what other farmers are doing around your area. They have lots, the good thing about technology, they have lots of visual things that you don't even have to worry about the numbers. You can see here in this example saying, well, these are my crop coefficients or field statistics, as they call it here. And you see, if I am within this dark, bar, I'm doing fine. And you can see this is for, for citrus. My irrigation management has been really good for most of the season. And, I'm not stressing my trees. I'm not over irrigating. Maybe here early on, I did over irrigation, So you could see I'm just wasting a little bit of water, but most of the time I'm just doing good with irrigation management. To summarize, it's essential that you know what type of soil that you have, because it has a big impact on the decisions that you will make in terms of irrigation frequency and how much you can hold, how much moisture you can hold in the soil profile. It will also make an impact whether you'll have salinity buildup or not. If you have lighter soils and you have a little bit of over irrigation, salinity may not be a factor. But if you have a heavier soil and you always have ET, evapotranspiration, going on, and the salinity is left behind, we need to do leaching once in a while. We want to consider irrigation water quality. If I have good irrigation water, I would not worry about leaching at all, because salinity is low. If I have high salinity, I may have to do leaching more often. We want to look at the irrigation system. Do I have drip irrigation? Do I have micro sprinkler? And I want to make sure that I have, a flow meter to tell me what's going on. If my flow meter is showing higher than the design criteria, I'm sure there is a leak somewhere and I need to fix it. You want to look at variable irrigation, and especially if you have a slope and different topography within the farm. You want to have different zones, different application rates, and different irrigation frequencies. Energy cost is a big factor. Energy is getting more expensive. So we want to make sure that we have that considered in our irrigation management decisions. There are several ways where you can estimate crop water requirements. And the bottom line is you have to fine tune whatever recommendation that you get from any sensor or from anybody. You have to fine tune based on the conditions that you have in the soil. And we have newer technologies that I think Daniele will talk about, which is basically forecast ET. Now I can look at ET over the last week, but now we have the technology in such a way that I can predict ET for the next week or for the next 10 days. It's very similar to predicting the temperature, for the next few days. On your phone, you could see what the temperature is going to be over the next week or so. We can do the same thing with reference evapotranspiration. And with this one, I'm going to stop here and turn it back to Mary Lou.